Alright, exciting projects. This is a gonna be a chicken coop, and here's the prototype shape of the chicken coop. This is called an egg coop. How does this work? It works with a simple half-lap 45-degree joint. Now, as you can see, these aren't put together perfect, but they are very, very strong. If I can get out of my own shadow, get a better look on this side. Okay, now these are just screwed together for now. You can glue and screw them, you can nail them. So it's a little off, but you know, this hasn't been set, so everything kind of is movable. Okay, but I can do chin-ups on this thing, and it's not even put in the ground or secured properly. Kind of see the layout of the joint here, and it's done the basic half lap. Here's a good example of a yeah, there's some shadow there, sorry. Here's an example of it. What we're doing here is we're creating a 135-degree angle, which is self-aligning and self-reinforcing. This joint is rock solid. The only thing holding this together are 3 screws, and it just doesn't even have a cross member. Okay, but I mean, I can drive a truck onto this doghouse here and not worry about it. You know, this is your basic structure right there. It's basically a 45-degree arch all the way around, 135-degree angles, 65-degree angle on the bottom to bring you level to plane. What we've done with the chicken coop is we brought that all the way around to another side and dropped our 65-degree inverted angles in the bottom to level it out. And this is the structure I wanted for the chicken coop. 6 feet wide, 6 feet tall, in this configuration. Eventually you'll see the finished project on another video. So let's talk about, and this is built here, and you know, I have nothing here that's level. I have nothing here that's straight. Okay, this is all rough, roughing it, rough. Set up a piece, and so this is the piece that was just done. This is the top section, the 18-inch top areas, right? And all this is setting. Let's shut that off for a minute. This is set into the saw, and you know, 45-degree cut, and hollowed out, you know, with the blade, bringing it to basically a half lap at a 45-degree angle. And you take the identical piece and you flip it around like this, and you make the same cut on the other side, diagonally opposing. And when you put them together, you can take them and make basically a reinforced octagon lap joint that self-aligns and reinforces itself. There's a stick or something in there. Okay, see, put those together like so. And of course, if I had 1, 2, 3, 4, 5, 6, 7, 8, if I had the other two sides, you have a perfect octagon. Done very simply. Now, what I wanted to show you was the only trick to this, really, is as you see the corner? See the corner here? So your initial cut, you come down, and what you need to do is just get a little bit past that edge. Take that corner out. If you don't get quite to it, or just at it, is fine. If you can get every cut perfect right at the edge, that's fine. But I give it a little bit extra over the edge to take out that corner, because if you don't take out this corner, the joint won't lock. It just won't. So it's better to go past the edge a little bit, couple of blade widths, rather than not enough. And that's it. That's the only secret to that joint. Very simple, 45-degree half lap joint. So I'll do a quick example on this. Basically, you're going to look at the edge here, you look at the blade there, and you're going to bring it across and try to line it up to the corner. I mean, yeah, you can use a T-square and mark it and all that. That's all fine. And bring your saw in. Now, as you can see, that was pretty much a dead-on alignment right to that edge. Okay? What we want to do, though, is we want to get just a little bit past this edge. So we're going to scoot it up a little bit and run that again. Now you see we've gone past the edge here. That's fine. Everything else, you just hollow it out. And I'm doing this one-handed while holding a phone. But, you know, you get the idea. Obviously, I should be holding that piece. So we're going to stop, you know, being dangerous. Of course, you know, this is treated lumber. It's treated with copper sulfate. So it's the least toxic of the treatments. It's just standard $3.50 landscape timbers. And, you know, disclaimer, hey, not for structural use. Okay. But build a chicken house or dog house, it's fine. Now, using this technique and this lumber, I will be building an 18-foot by 18-foot, 10-foot tall storage shed using these techniques. You'll see that in a future video. And we'll go over the whole thing then in more detail with a more professional filming using a tripod, etc. But remember, you know, if you want to be deadly accurate with this, you know, you can run this with a radial arm saw. You can run it with a table saw. Okay, you can do all these techniques with a table saw. Okay, just set your 45, set your blade height, you know, for your half lap, and slide it across. Got dado blades? Use dado blades. If I had dado blades, I'd have dado blades on there doing this. So I don't have to take as many passes on it with the blade. You know, this blade cuts firewood. Okay, this thing's been beat to heck over the last year and a half. This saw, you know, the table's not exactly in great shape anymore. You know, it's almost straight, etc. You know, there's some pieces of the back fence missing, etc. But that's, you know, that's from use. Obviously, when this project is done, this whole table will be replaced with a proper table. But until I get my workshop built and this goes indoors, I don't see any need to waste my time putting a brand new tabletop on this thing. As long as I can still function with it, I'll hash it out, I'll pound it down, I'll adjust the screws, I'll bring it to level, and for whatever project I'm doing, you know. But the radial arm itself will give me my appropriate angles and heights, and it's been adjusted so there's no wobble or camber. And when I cut something with it, it's as set, you know. This does not wobble around. It gives me my 45s, gives me my 60s, gives me my 90s. I can tilt the blade and do whatever, you know, compound angles I need to do. It's just a matter of setting the tool up correctly. Now, it's getting beat up out here in the weather. I mean, literally, it stays here. All I do is throw that tarp over the top with a couple of bungee cords, and it gets rained on, snowed on, you name it, you know. But, hey, got to start somewhere, and this is how we're doing it here. But I wanted to show you those joints, because those are the strongest and simplest timber frame type joints that I could come up with without a modicum of, you know, this thing will go together in a day and a half. And in a day and a half, I'll have a new chicken coop up there. And you'll see that in a future video. Till then, back to you, Chet.